What's up guys, it's me Kyle back again with another video, and today I wanted to do something with this Pro Micro. Well, actually I started with this. Okay, I did not make this first and then thought of myself what I could do with it. I wanted to make a steering wheel for PC games, such as racing games or even GTA 5. Thing is, I've got a potentiometer back here with 3 leads, really easy, and well, this wheel, this steer here is a bit of a prototype still. It's made out of duct tape and plastic and it's not very great, and the woodworking is still a little bit crude, as you can see, but it will do. And I made this because I already got it working, so otherwise I wouldn't have made it. But this is a steering wheel with a pot meter, so that means we've got an analog signal if we steer like this. Alright, fair enough. How can we use that? We want to turn this analog signal into some kind of signal that can be used in a game. And a thing that uses analog signals that can be used in games is a controller like this. This is a PlayStation 3 controller. I've just got it laying around in my room. And this is basically 2 pot meters, one for this motion, one for this motion, and this one is the same. And like this, you can steer in a game, which is slightly right, more right, and then maximum or the same with going to the left. It's pretty neat. But keyboards don't have this feature, so we need something like this with a pot meter. And we also have this device. As you can see, the Pro Micro is not just any Arduino, because you can see there's one chip here, bit of a voltage regulator, couple capacitors, not much, and there is nothing on the bottom, absolutely no chips. So everything is done in here. Also, this one is just directly connected to here. Well, maybe a couple capacitors or resistors, I don't know, but there's no chip in between. So there's no FTDI chip to program it. That's this chip itself that does that. And the neat thing is, we can program this chip directly from the Arduino IDE. And we can set this to be a keyboard, we can set this to be just an Arduino, we can set this to be a controller, like this one, or an Xbox controller thingy. There's one little thing, we cannot set this to be exactly an Xbox controller, but more on that later. First of all, we need this to be a analog input device that says it's a controller. Well, we've got a library for that, really easy download. I've got some code for you, which I will be going over in a couple minutes. It's really neat. And connecting it up is really simple. What I do want to say, by the way, is this is the Pro Micro that has been sent to me by the 5-Shine Technology from Hong Kong. Or also Highlight Go, they go under the same name, under different names, but it's the same thing. I will link the video down below if I don't forget to do that, in which I show you that I got these, and I'm still really grateful for this, because this is really cool. This is really neat. So connecting up is really simple. You take your middle lead from the pot meter and connect it to one of the analog inputs of your choice. I've set it to A0 in the code, so I'll be using A0. And the other one, the far right or the far left, doesn't really matter, goes to VCC and ground. Doesn't really matter which way around you do it. But if you get problems with when you turn to the right, it goes to the left, then you just have to swap these leads around. That's not that big of a deal. So one goes to VCC, this one goes to ground in my case, and the other goes to VCC. That's it, 3 leads and a USB cable. That's all you need. Now you might think, I don't have an Arduino Pro Micro or Micro, both will work in this case, or Leonardo. All three will work actually. You might think, well, I don't have one of those. I will link some in the description. They're not that expensive from China. And I will also try to link some pot meters if I can find some from China with a longer shaft thingy over here. But you can also use an Arduino Uno. Well, it has to be a genuine one, as far as I know. And then you have to look up Uno Joy. I will link that in the description. Uno Joy. That's joystick for Arduino Uno. But you can't use the code I wrote with it for that. You have to use different code. And you also have to do a lot more work. So that's why I chose for this one, because it's just a lot easier and a lot cheaper. But if you already have an Arduino Uno from the Arduino website, then it makes perfect sense to use that one. But if not, get one of these. They're really cool. You can make all kinds of projects with these. So look in the description and see what you think you can use. Really, it's up to you. Now, coding, very important. Okay, so this is the code, and as you can see, it uses the joystick.h, which is the joystick library. If we go here, we can see that this is the Arduino joystick library. This is the Arduino joystick library 2.0.5. It is to create joysticks, gamepads for an Atmega 32U4, which is the Arduino Leonardo and Arduino Micro, or the clones of it. As you can see here, you can see features, and you can see some instructions, some examples. So it's pretty neat. But my code is this. It's really simple. As you can see, it's actually really quite simple. And I'm just going to explain it to you so you can edit it yourself. So as you can see here, we have an include joystick.h, so that's the library that we need to use, so we don't have to write all of that ourselves to make our lives a little bit easier. Well, actually a lot easier. And over here, we basically initialize the joystick and the library a little bit. The library initializes, not quite sure how to explain this to you, but it's basically like create joystick out of this Arduino. So this is just an integer, and that is basically for the analog value that I'm going to read from the potentiometer. So I call it xval, because we're going to move the x-axis of the controller that we have. So we have the left thumbstick of the controller. That's what you use to control your car with in GTA 5, for example. That's the one that we're going to basically emulate with our one little potentiometer. But we don't want to go up and down, which is the y-axis. We want to go left and right, which is the x-axis. So that's why it's called x. And then value. And I just give it value 0 for good measure, because if it's nothing, we just, if it's nothing yet, I just give it a 0 value. Why not? Just to be sure. Then we have double. This is basically a float, but more precise, takes up more space in memory, but I thought it's such a simple code, just use a more precise float, basically, just a double. Why not get the best value we can? It is not an integer, because this needs to be a value that has decimal points, and that is because I'm using a multiplier over here. We'll get to that later, because the x-axis, as you can see, that is obviously the value for the x-axis that we're going to give to the computer, as we're going to send over USB. So integer potentiometer pin, so this is the pin that our potentiometer is connected to. Well, maybe we should, I don't know, maybe some people want to neaten this up like so. So we have integers and then double float. Why not? There you go. Doesn't really matter. The potentiometer pin, as you can see, A0, that's the potentiometer pin. You can change this and then it will work in the code, as you can see, because this is just the integer over here, where we do the analog read. Then we have the double again, and here's the float. This is a float because we have a decimal point, as you can see, and this is the multiplier. So this is to change a bit of the formula we have over here, and I'll explain that in a bit. Because we have a potentiometer, and you might have a different one than mine, but mine has quite a wide range. But if I were to use all of that range, I would have to turn my entire wheel to the left side all the way just to turn left, which I simply can't do fast enough in racing games, because you need to go fast, and if I go slow, then it's gonna be horrible. So my multiplier is just to reduce that, and you can change this value. You can set it to 1, you can set it to 0.5, you can set it to anything you would like in order to make this work better for your joystick. You need to use the serial monitor, as you can see right over here. Just click on that and see if it feels right, or you can just go to your control panel, which I'll go to next. I'll just show you that in a bit, but you can change that. So here we have the joystick.setAxisRange. That's basically just from this library again. That's the set the range from minus 127 to 127, and also for the Y. Now you might be like, but we're not going to change the Y value, so why would we do this? This is basically because I'm not quite sure, but I had a couple problems with the Arduino sending gibberish Y values, so I just included this in it, and then I just set it to set axis to 0, the Y axis just to 0. Why not? That's just the middle. We're not going to mess with that, just to be sure. And here we say joystick.begin, so it's basically begin the joystick output to the computer. And here we have a 0 begin, which is commented. You can change that to like this, as you can see. Now you can use it in the Arduino IDE, but when you're done with troubleshooting, you comment it out. And if you don't do that, your controller is probably going to behave very weirdly. It's going to be a terrible experience because it's still sending things over your serial port. So comment that out. It's going to make your life a lot better. So in the loop, we're just saying, okay, read potentiometer pin. That's the X file. X-axis is what we're going to send to the computer. This is what we read from the pot pin. And as you can see, we have a 0.2482, a rather strange value. Why is that such a strange value? I'll show you. If I get my calculator here, we're going to look at the range from our pot pin, and if we print that, we can see that it is all the way from 0 to 1023. So in total, that's 1024 values, including 0, of course, very important. But we're doing this now mathematically. So 0 to 1023 is a delta x of 1023. So our input value is all the way from 0 to 1023, and our output value should be from minus 127 to 127. So that is 127 times 2. That's the delta y we have, okay? 254. That doesn't mean we have 254 values, but we have a delta y of 254. If we divide that by delta x, which was 1023, we have 0.248, blah, 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 whatever. I just typed it into Google, copied and pasted it in here, whatever. It doesn't have to be exactly precise. But I just copied and pasted it in here. And this is basically our mathematical equation that we're going to use. So it's just a linear formula. We used this times our value that we read from the potentiometer minus 127, because that's the minimum value. That's where it is when we have 0 from the potentiometer, we have -27, which is all the way to the left. And then we do that all times the multiplier to optimize our experience a bit with this multiplier. So you change it here, not here. Otherwise you get so this looks like a strange formula, and it is a bit weird because you would say, well, of course we've got 1024 values, but mathematically we don't work that way, because otherwise we'd get a different value and it won't work anymore. This formula here works pretty well and doesn't have to be completely precise. Doesn't really matter. I was just like, well, let's just do this calculation already and just paste it in here. So this might be confusing to you, and this explanation might not have made it completely clear, but I hope it does make sense to you a bit. And here we just say, for optimization purposes a bit, just to make sure nothing really gets out of hand, say if the x-axis, which is this newly calculated thing, which is between -127 and 127, if it's smaller than -127, so it's like -128, it's outside of the range. That's not good. So if that happens, set it back to -127. If it is bigger than 127, it's also out of the range, so let's just set it back to 127. It will probably work without this. I could probably just comment this out and it would probably still work, but maybe not for you. I don't know. I just have this in here just to be sure. I didn't have any problems, but I just wanted to make sure that that wouldn't happen. And then we just say set x-axis value to our, and this is a bit confusing like this, but to our calculated value over here, and then changed over here. If any of these things is the case, then we set the y-axis to 0, because we don't want to change that one, but we still want it to be in the middle so our camera doesn't go up all the time or down. And then we say send state. So we just send this information to the computer, and then we start it all over again. So hopefully you completely understand this bit of code, so now you can program this all differently if you want. And you basically just go select your Arduino and press upload, and that's it. That's all you have to do as far as this goes. Now for Uno Joy, as you can see, here's the Uno Joy. You have to do quite a bit. Here's Uno Joy, you have to do quite a bit of things. It's not terrible. It's pretty great. It does work quite well, but you do have to follow some instructions. So just look up for some Uno Joy instructions. It's not quite easy compared to just uploading a sketch from Arduino IDE to your Arduino, but it will work, and you have to flash something to the FTDI chip on your Arduino. You can reverse it, but it's a lot of work, so I just gave up on that because my results weren't very great. Now you're in control panel. You might be like, why? My controller is probably working right now, right? Not quite. Just go to your hardware, your devices and printers, and if your Arduino Micro or Leonardo is plugged in, you will see it pop up over here as a game controller. And I'd be like, great, awesome, that's exactly what it's supposed to do, right? Yes, it is, but it doesn't mean it's going to work in games, and I will explain why. So over here I've got my Arduino Micro, and if I go to this panel over here, if you press Windows key R and you type in joy.cpl, and it will give you the same panel, and you can go here, and if everything is alright, you go to the right, it goes to the right, go to the left, goes to the left, and yeah, oops, I'm messing some things up over here, that's not good, but as you can see, that's working. That's an analog value. Great, success. That wasn't too hard. Sadly, this does not work for all games yet. Also, you might want to change some of these things over here. As you can see, they're all weird values. You can change that around in the code if this isn't great for you, but for me, I don't have to do anything about this because It's not bothering me because I have one simple problem, and I will explain to you that on camera really quick. Okay, so to explain this to you, I'm going to make a little bit of a block diagram to make it easier. So I'm going to make a little block over here, and this is the pot meter. As you can see, my writing is terrible, but it's fine. So this is the pot meter, and it goes down into the Arduino we have. It's another little block, and that converts it into some joystick values, which is a bit strange. What is joystick values? So in our case, it is a method which is really easy for DIYers. Yeah, it's easy to program with for Arduino, and it's the input. And I have tried, and for the life of me, I am not good enough to change the fact that it's the input. You might be like, what's the input? The input, what is that? Well, it's a certain and sadly older method of sending values to your computer of buttons and joysticks and controller things, values, all kinds of stuff that you would want to send with a controller from, let's say, your PlayStation or something, or maybe even a Nintendo controller. You can do that too. But the problem is most modern games require this one, X input, or X input. It's X input, which is obviously Xbox input. It's Microsoft's newer Xbox 360 and Xbox One input. So if you have an Xbox controller, this is the reason why your controller works with almost every game. And if you have a PlayStation controller, this is the reason why it doesn't. It's not X input. So that's why you have to convert your PlayStation controller to X input somehow. We have to do the same, unless we have something that supports D input. So you'll have something like Gangbees, which I know has the setting for X input. You can turn it off, and then it will maybe work with D input. I'm not sure, I haven't tried it, but I'm pretty sure that it should. But the problem is, let's say we want to play a racing game, or GTA 5 even, which you can play with this steering wheel, and it does not have any options for D input as far as I know. It requires X input. So we need to add another little block that says X input. I forgot wow, that's really bad. I forgot an N there. Ooh, no. Oh no. This is why my teachers don't like me. I can't write. So we want pot meter Arduino D input to X input. So we need some software on the PC. This is all on the PC over here. So this is PC, and this is our hardware. Let's just call it hardware. And my pen is dying. That's not good. So this is our hardware. This is PC side. And this should then go into the game. There you go. This is a bit of an easy diagram. And luckily for you, this is possible. This will work with anything that's the input, which is probably something like Gangbees or emulators. Because emulators are, if you have open source emulators, somebody came up with the idea, hey, let's use the input instead of X input only as well. Which is great, but something like AAA games, they all use X input as far as I know, except for a couple probably. But we can do this part as well, and this possibility is also a possibility if you just do this. There we go. The input game. This is also possible. So we can do all games that support a controller. So this is awesome, and I will show you how to do it. It's not that hard. So the way we're going to turn our D input into X input is by X360CE, which is Xbox 360 controller emulator. That will work with basically any game. And as you can see, it's over here, and last commit was 20 days ago, so it's still active. And it will work with a lot of games. And the download is right over here, so don't download this entire thing. This is the source we want to download here. And you can see there are some guides, some compatibility things, some system requirements, very important. Follow these. And some games require a d-input.dll. Now, you might think to yourself, what the heck am I supposed to do with 32-bit, 64-bit? Do I need both or only one? I suggest you just take your game, look it up with this term x360CE. Chances are you're probably going to find something because it's a very popular program. There are all kinds of little issues that you can find over here with these DLL files or setting up files with the program that people have already solved. There are also 361 issues over here. A lot of them are solved, so just take a good look, and chances are somebody is able to help you if you can't find it. So I'm just going to show you how to do it for most games. As you can see, I've got the 64-bit version because I'm going to be using it in GTA 5, and you just simply get a .exe file, and that's it. What you want to do is you want to go to your game file, and you just simply drag and drop your .exe into your game file folder where your .exe of the game is located. Here, if we take a look at Don't Starve Together, for example, the game file would be here in bin and not in here. So that depends on the game you have. In GTA 5 case, in the case of GTA 5, it's right in here. Drag and drop in here, but you're not done yet. You're supposed to open it as well. And it will load and it will say DL was not found. That's fine, you just press create, click that button, because that's your DL file for your X input, and it will detect your Arduino, which is great. So just press next and finish. And as you can see, this might not be the case for you, but for me, it detected this perfectly. So you want to set everything to nothing except for your stick axis Y. And if it says empty or something else, as you can see, it no longer moves. Press record, and you simply do a little twist on your steering wheel, and it is working now. It's working fine. So that's great. Save. So now we go to game settings. Very important. As you can see, we see all these things here. If GTA 5 or whatever game you have is not in this little list, press add and then go to your game and add it. There you go. If this isn't added, it's probably not going to work. Make sure that when you press, as you can see, I can click on these things. If I click here, that the right X input file is selected. So you might be like, okay, which one is the right one? Simply go down. You can also look this up, but you can also go down if you have created one, and you can see here 1_3. Ah, that's the one this program created. So that's 1.3. 1.3, 64-bit, because you downloaded the 64-bit version of this. If you do 32-bit, it's not going to work. It's going to crash. Your game's probably going to crash. So, not good. Get rid of that. Let's try it again. Just to be sure. Create. Next. Finish. Great. It's working. Nice. Game settings. And this one is 64-bit. And if you see this button, click this. If it says issues, all is okay. Good. If it gives you an issue, look it up. Oh, no, this one is not supposed to be clicked for GTA 5. I don't have this exe. So, as you can see, sorry, I don't have this exe. I do have the 64-bit version. This one I don't have. So, it says executable is not found, so you can basically delete it, because we only need one for this particular game. All is okay. I'm just gonna set this to 64-bit. Why not? That should about do it. And now we can go back to controller and left thumb. And as you can see, if I move it, we have very nice values, which is great. And what I want to do is you have sensitivity, which we can do like Okay, let's redo 100%. It makes a couple annoying noises. And as you can see, this is making it... Okay, so this is not really what we want. So when we press invert, there you go. You can see the value goes up rapidly, and then it decreases. And it goes down rapidly, and then it decreases. The speed of which it decreases. Speed of which it increases, decreases. So that's pretty neat to have. You can also play with some anti-dead zone and some dead zone. And I want to set this about to 55-ish. Sorry for the annoying beeps, Jesus Christ. I don't know why this program does that, but it does. And as you can see now, we have a little bit less linear steering, which is quite nice actually. So I'm going to save that. And be like, okay, well, what if I don't want linear steering with D input? I'm glad you asked. You open up your steer.ino, Arduino file, and you change this to basically anything that you would like it to be. You can play with some formula. So basically what you can do is you can go to decimals, graphing calculator, and you can do let's say x to the power of 2, and well, this is not very great. So you can do log x. We've got a logarithmic function, which is nice. We want to increase something really rapidly and make it decrease in the way it is increasing. That sounds a bit strange. But we can also say x to the power of 3, and that gives us, so when we go to left thumb, you can see this is the inverse of a x to the power of 3 function. So we inverse that. That's not what I wanted to do. There we go, inverse. And yeah, we're kind of getting the same function, kind of. We have to do some transformations to it, but you can just play around with it, look up some things online, and I'm sure you'll get there. So just use Desmos, it's great. I'll link it in the description, why not. And the great thing is you can change per game with this. Only thing is, I don't know how GTA 5 online services will react to these files in the 10th out of 5 folder. That's the only downside to it. By the way, when you're in here, I forgot to mention, you want to go to this panel, press Advanced, and make sure your Arduino Leonardo or Micro is selected. Okay, good. Now it's good. So now this part is very, very important if you're using Steam. Steam intervenes with your controllers because it's really nice that it can pick up your PS3 controller, for example, and you may be able to map it, and then you will be able to play without any unnecessary drivers then. But there is one downside to this, and that is that Steam does not work very well with our controller because we're using the X360CE. And so what we need to do is we go to our game, and then we press Properties, and there we have Steam input per game setting, requires restart of game, and then it's input settings. You turn it to forced off. If you do that, your controller will work, your mouse and keyboard will still work, everything will still be fine, but Steam will just not be intervening with your mouse and keyboard or controllers for this particular game. It will be directly from Windows input, and that way X360C will be able to work. Very, very, very important. This took me quite a bit of time to figure that out, until I just turned it off. I was like, what is that? Let's turn it off. And then X360C works perfectly fine for me. So very important. If you use Steam, turn this off, forced off. As you can see, I'm in single player, and when I get in the car, I'm going to have to cut that bit out because demonetization, because music is going to play. Okay, so I turned the radio off because I don't want to get demonetized. And as you can see, when I get on the road, so as you can see, I can steer using analog values. So you can see these wheels, they will go very precisely to where I steer, which is really nice. So if I just drive a bit, I can just, if I don't go too fast, Jesus. There I go. And you can see it works very well. You need to play around a bit with some curves and some formulas and maybe some multiplier, but the end result will be working. And oh my god, it's going a bit. I'm not very good at steering like this because I'm using my hands only to drive, and when I press my keyboard forward, I go either full throttle or not. So this is only all just a prototype, because what I want to add is analog pedals, analog brake, analog gas, which would be pretty cool. So as you can see, Sapphire, egma.io/edits. I got it recommended from try to make a steering wheel. Well, that's this video, so thank you for that. It's a great idea, and I think that making a GTA episode of online races would be quite a nice thing to do on my other channel that's a bit dead, but hey, why not? Great idea. I'll try to do that once I've got, you know, the time to play with this thing. I do have to optimize it a bit. Sorry that it took so long though, because I only just realized that the Arduino... Sorry that took so long though, because I only just realized that the Arduino Micro could be a controller. Bit stupid, but yeah. Sohu or Sohu. Sorry, I don't really know how to pronounce it, but it's really cool. But what about potentiometer pedals for racing sims? Yes, you can make those with this, and I will. I will integrate it all into this one Arduino, because that is more efficient and cheaper. If you were to use two Arduinos, it's not very great. So you will have steering wheel, analog steering wheel, and two analog pedals for racing simulators, which would be pretty great. I mean, it's a bit crude, but not too bad. You can set it to be any input you'd like. So I hope you enjoyed this video. I hope it all made a bit of sense to you, and I hope you learned something. And I also hope that you will be trying to make this, because make it better than mine, because this is duct tape and stuff. It's not very great. Maybe optimize the code a bit, I don't know. But if you enjoyed the video, you can like the video, or you can not like it. Doesn't really matter. I mean, I don't get paid on YouTube anyway, so that's fine. So I hope you liked it, and I'll see you in my next video, I hope. So bye guys.